Welcome to Industry Tech Days 2021, brought to you by Tech Media and All About Circuits. I'm Daniel Bogdanoff, and I'm your host for this event. Strap on your learning hats because this week is going to be jam-packed. Industry Tech Days 2021 is a free 5-day virtual conference and trade show for engineers and technologists like you. Each day kicks off with a live all-star keynote, followed by a lineup of live sessions featuring industry experts, professional training, and interactive Q&As. You can also browse one of the 30 digital booths from your most trusted manufacturers and distributors. And of course, there are over 100 giveaways. Each giveaway includes a soldering mat and a t-shirt, and one lucky attendee will win a grand prize from DigiKey Electronics, a fully loaded InstaLab kit, including test gear, tools, components, and more. The more live sessions you sign up for, the more chances you have to win. You can sign up for all 50 live sessions right now on the event webpage by going to allaboutscircuits.com and clicking the Industry Tech Days link along the top menu. Then scroll down and you'll see a schedule of this week's 5 live keynotes, followed by the full schedule of exhibitor live sessions. We have a great keynote guest today. Really, every day this week, the lineup is stacked, so while you're on that page, just go sign up for all of them. Live sessions then will kick off right after this keynote. You can go check them out. Today there are a couple topics like next generation thermoelectric coolers for optoelectronics, carbon dioxide sensing, and the pitfalls of overcurrent protection. And there's a bunch more. Go check them out. This keynote is brought to you by OKDo. OKDo is a global technology company specializing in single board computing, education, and IoT. They work with leading technology companies and offer customers the latest products, innovations, and design services wherever they are on their SBC and IoT journey, from students to entrepreneurs to professional designers to engineers and developers. Today's keynote is with Arduino co-founder Massimo Banzi. He's an educator, engineer, maker, and innovator with stories to tell about how Arduino became a staple in the world of electronics. Historically, you might think of them as kind of a beginner's board because Arduino products are often found in university labs and even elementary schools across the world. But Arduino has been making quantifiable studies to become a viable professional solution for production environments and can be found on the desks and in the labs of professional engineers worldwide. Today, Arduino hardware is moving into real-world industrial applications, and Massimo Banzi is here live to tell us more about how Arduino is going pro. Let's bring him on the stream. Massimo Banzi, thank you so much for being here. I'm thrilled to have you on as a keynote. Can you give us your background of you and of Arduino?
Thank you. It's great to be here. My name is Massimo Banzi. I'm the co-founder of Arduino. My background is, I originally studied electrical engineering, but I ended up working a lot with designers. And so that's why I kind of tend to work in this space called interaction design. And that's where, in that world, is where Arduino happened as a tool for innovation and prototyping in that space.
Great. For me, Arduino was something that really made embedded coding and just coding in general accessible to me. I was in school kind of right around when Arduino was rolling out and starting to see that, now it's a household name. It wasn't necessarily a household name. It's like, what is that thing? And I was, coding registers and like, oh, this is rough. But being able to work with Arduino has been really, really great for me personally. And I know that's true for a lot of people. Can you talk about what the impact of Arduino has been on both the engineering community and the maker community?
Well, it's been an incredible journey because, I learned electronics as a kid by basically messing around with things. And, whenever something didn't catch fire, it was an experience that, okay, now this is working. And I also had the chance to do some assembly language programming back in when I was very young. And I sort of decided that I didn't want to go there again. So when I started working in this design school where we came up with Arduino as a result of a number of projects that we did there, I guess originally the idea was just to create a tool that would be useful for a very small community of designers who create innovative products and give them the ability to prototype with technologies to discover things that you don't discover just by, on the drawing board. So that was kind of the start. And then it sort of escaped from that lab in a way. Other schools started to use it. And then obviously that was the time where makers started to become a thing. So obviously a lot of makers adopted Arduino. And we really seen really like millions of people just really learning how to program microcontroller. And I have to tell you, at the beginning, it was kind of funny because obviously a number of, not a huge amount, but a small number of, let's say, professional embedded software developers, they were, either making fun of us or they were literally saying that we were poisoning people's minds with our system because obviously they saw the tool as way too abstract. But it's that level of abstraction, that kind of ability to kind of look at things from a little bit higher up, that gave you the ability to really start very, very quickly. In fact, in Arduino, we really have this, one of our mottos is we really work to simplify technology to enable almost anyone to innovate. So we really want to create tools that allow almost anyone to use electronics to build something. And so in this arc, in a way, it started to get used also in engineering schools to teach uh, young engineers how to approach embedded development, or a lot of people in spaces that are not about electronics or electrical engineering, like mechatronics or even biology or chemistry, they started to use Arduino. So I think there is a lot of, in a way, interest in the world for anything that would make complex technologies simple to understand and turn them into a creative tool. I think that's been clear for the number of people. Consider that Arduino, the development environment, gets downloaded almost 40 million times a year.
Wow,
So
40 million.
it's,
Sheesh. That's like
yeah, it's insane, insane.
how have you seen adoption beyond, you mentioned being creative. How have professionals and professional engineers started to use either the IDE or the hardware in more professional ways that maybe have surprised you?
Well, so one of the other things that we found out during these years of working on Arduino is that Arduino is simple for beginners, but it's actually fast for professionals. So we have seen basically, I don't know, probably most of the Fortune 500 companies have used Arduino as a way to invent, prototype, build different bits of equipment they use internally. If you go to LinkedIn and you search for jobs with Arduino as a keyword, you get Microsoft, Ford, Google, Apple, you know. So I think one of the things that, in a way, professional engineers have realized that with Arduino, they can make realize an idea incredibly fast because there's no boilerplate code to write. Because some of the professional development environments are in a way organized so that every time you start the project, you almost start from scratch. While we basically say, hey, we give you essentially a working thing. You just have to add your own code in a way, and I think that's quite an important feature that professional engineers like. Also, one of the things that probably will come up a couple of more times during our conversation is the definition of professional engineer. No? Because we work with people sometimes that are professionals in their field, but they don't have a background in embedded development, but they want to use the technology. So you might have people who work, for example, on agricultural equipment. They might be software engineers, they might be mechanical engineers. And so, in a way, Arduino enables them. Uh, so they are still professionals, but they're not the classic embedded engineer.
That makes a lot of sense. Even inside of electrical engineering, there are so many different disciplines. I focused a lot on power in school. So, you know, if you wanted me to design a buck boost converter, I think I'd be okay. But if you wanted me to drop a microcontroller onto a board and make it all work right away, it'd be a little bit challenging for me without something like Arduino. So that does check out, I think, in a lot of cases. And rapid prototyping, we've definitely seen a lot with 3D printers, and you know, you walk around a prototyping lab these days, and it looks very different than it did 20 years ago. I know I've seen Arduinos in our development and prototyping labs at the Keysight labs. Um, is Have you seen it in like industrial automation and that sort of area, or has it more just been like a rapid prototyping type environment?
Actually, that's an interesting that's a very good question, because one of the trends that we started to notice is that there were more and more projects that would pop up on the internet. They were about, in a way, industrial automation. And so you had, it's usually, small and medium companies, where they want to build maybe some piece of equipment. Sometimes there's even a piece of equipment they use internally. We're also talking about companies that make a few hundred units of something. And in a way, I noticed that there is quite a bit of, how can I say, dissatisfaction with classic industrial automation tools like classic PLCs, because for some companies, they complain about the fact that it's very expensive, the hardware is expensive, the people who develop the code are expensive, and it's sometimes not very easy to train the people who work there on that particular technology. And then there is always the person that shows up with Arduino and says, sorry, but if we take this Arduino and we connect this thing, also because PLCs have a clear place in the world of automation. But it's not that every single company has to build this insanely mission critical stuff. Sometimes people build very simple piece of equipment, or something where they want a little bit more freedom. And there's always people who know how to use Arduino. Also because imagine, if you're a small and medium company, you always have a hard time finding very good engineers, because obviously the big companies, they steal them from you, no? But in a way, it's interesting because you can open the door and you can grab a random person who went to a technical school in the last few years and they know about Arduino. So for them, they can find the people very easily. Arduino is no longer an 8-bit toy. There are now very sophisticated multi-core 32-bit processor boards. The code is much more sophisticated, so now they can really build. And we have examples. We work with a company in Italy who builds equipment that goes into car factories. So maybe the machine that works at assembling a car door. They were said, okay, I'm done with PLCs. He just hired a bunch of young people from university, and they used Arduino. And now this company is called IDT in Italy. They use Arduinos to build all sorts of stuff that then ends up in a car factory, or they built a machine to test coffee machines. It just presses the buttons on the coffee machine, and it
I
goes
test my
into the
coffee machine
factory
every
as
day.
well.
Yeah.
Yeah, but in order to make sure that when you press the button, they do work, somebody in the factory has been.
Sure.
And so, yeah, so they do very interesting work. And, there are a number of examples of people who want to, they are adopting Arduino in a more and more industrial, mission critical project.
Yeah. So you've mentioned training and you talked about professional engineering. I've found that different parts of the world, calling someone a professional engineer maybe has different meanings. So to you, what is the definition of a professional engineer?
Well, in fact, you're right. Like, for example, in some parts of the world, like Italy, in order to be called officially an engineer, you need to take an exam given by the government. So there is a government enablement test that you have to take before you can actually call yourself engineer. No? So obviously, but in a way, you know, almost everything we're building nowadays has got digital technology inside. And so there's a lot of people who every day build with electronics, with software, with sensors, with connectivity. So there's a lot of people who combine all these different skills at different level to either design, prototype, or even build equipment. And obviously, when you look at Arduino, as I mentioned, a lot of people think about the classic embedded engineer, but that's probably not really the target for Arduino. We're not really trying to convince somebody who's got a very large experience in a certain set of tools to abandon everything and use Arduino. A lot of them do, but it's fine. But there is a world of people who are working in companies, they're working in universities, and they design and build equipment every day. So for me, somebody who combines this set of skills in order to design and build a piece of equipment, to me, that's that's an engineer, the kind of engineer I work with.
Understood. Now, is Arduino focused more on the maker student beginner community, or how you balance that with looking at more professional devices, especially now that you're not necessarily open sourcing or open sourcing your designs, or not all of them?
So we continue to operate across the whole board. So we have a part of the company that works on tools for education. So they build tools and classes and content to teach essentially from kids in junior high school all the way to university. There are different tools and classes for Arduino. That's all open source, and that's all classic Arduino, mission. And obviously that crosses over into what makers are doing. And we also build tools for makers. Obviously, when we started, the objective was how do you make programming a microcontroller simple? Now it's about connectivity, and now we are also touching more advanced topic like tiny machine learning, this kind of stuff. But then and obviously we have been working for quite a bit on this IoT cloud platform that kind of ties everything together. But obviously the market is going a lot towards the professional solutions. Companies are adopting it, so obviously we started to follow that direction. So I would say we haven't abandoned our mission. I would say the vast majority of what we do is open source, or on some products, for example, we have a delayed open sourcing to allow us to, to at least start making some money before people start copying it. Then in a way, to me, the mission of the open source part was to basically allow people to learn about a particular product. There are some products in our new product lines that are incredibly complicated. So they wouldn't, I don't think, what people need is to take these modules and put them in their own products. But the inner detail of something that's got a ton of layers and is super complicated, it's probably not very interesting to the kind of people who we talk to who are building solutions. Because at the end of the day, one of the things that it's, I think, key for Arduino is they always try to build solution. We always build software alongside hardware, alongside cloud, alongside the content that wraps everything together. So in a way, to me, everything has to have these elements. So in a way, we continue working with what we have done until now, but we have created this new space. I will close this answer by saying that it's also important to, in a way, to trace what happens. People start in school, then they start to use it for their own projects, And then when they go to work, they find Arduino. It's a kind of a, it's the full, it's the full cycle. And I think it's important to continue working on all these directions.
As you move into more industrial type applications, how much is ruggedness a concern? I know a lot of the processors are, automotive spec with temperatures and vibration, that sort of thing. Is that more of a concern, or has that always been integrated into your design fundamentals?
So we always try to build robust products because obviously one of our objective was really something should work out of the box. You should be able to plug the cable. It should just work. And so that's why every single Arduino that comes out is tested in the factory individually. So in a way, it's that particular aspect of reliability. For example, we still manufacture 95% of the products in Italy. So also because there are a number of, in a way, I can say, there are strict regulations in Europe about also emissions and pollutions and the processes you use to build. So for us, that is super important. Obviously, when you start going into a more pro kind of direction, you cannot use kind of consumer grade processor. You have to start to use other parts. So, for example, the new products, like for example this Arduino Portenta, which is kind of the core of the new sort of advanced products. As you mentioned, yeah, all the parts are industrial grade. It is certified for a number of different scenarios, including vibration scenarios, because the idea is really that you should be able to take that module, put it on a PCB, and build a piece of equipment that works. Like, for example, we built this thing that's called the Portenta machine control. Essentially, it's almost kind of like a PLC that's got a Portenta inside, and it's designed so that you can fit it inside a piece of equipment, and it will run the piece of equipment. It will connect to the cloud and all of that. And at the moment, there is a company who is actually building an oven. We're talking about an industrial oven that bakes products industrially, and it's all powered by one of these devices. So clearly, it has to be robust, tested, certified, and all of that. So I think that's the new direction for sure.
Yeah. I've played with the machine learning on the BLE 33 board, and that's been a hoot to play a little microphone and little automations around the office. Um, is that machine learning approach being adopted by professionals?
Yes. So that company that I was mentioning that makes machine that assemble car parts. One of the things they recently did, they took a Portenta with the Vision module plugged on, and they used a tiny machine learning computer vision algorithm, and they put this Portenta on a robotic arm. And when the robotic arm moves around the piece they have to assemble, it checks that the human operator has placed this. There are this metallic clip that you put into the plastic so that you can put screws through them. But sometimes the operators might forget. So while the robot is doing some operation, this Arduino is just telling them there is or there is not the metallic clip. That's it. They don't need anything more sophisticated than that, but there is no cloud, there is no connectivity. Literally, the device just has an output that says true, false. So I think there are more and more situations like this where
Yeah,
people just want to program a device.
I would love a robot checking my work. I feel like I would be maybe 100% or 99.9% effective, and I try to get close to that, but I'm not quite there. How did you know that Arduino was, I'm gonna say, going pro? And were there early adopters that keyed you in and kind of changed the trajectory or expanded the trajectory of Arduino? Or what were those cues, and what was that time frame? Because something like Portenta doesn't get developed overnight.
Oh, well, it's interesting because I think, well, so funnily enough, some of the Arduino products are uh, the byproduct of more professional work. So, just give you an example. At the beginning of the history of Arduino itself wasn't really generating enough money to really pay salaries. So we used to work, at least me and other person in the team, we used to work on a bunch of different consultancy projects. And then we ended up working with a company that was making a vending machine that was basically selling DVDs. And they started off with Arduino, but the Arduino Uno wasn't going anywhere. So the Arduino Mega was invented essentially to build a platform that would have a lot of IOs and a lot more code. And so then the Arduino Mega is the byproduct of us working with a professional customer that wanted a more powerful tool. And then you saw the Arduino Mega end up being adopted by people doing 3D printers, all sorts of other equipment. We started to get mails from people that there was a large, how do you say, petrol company, like the people who extract the petrol from the ground, that wrote to us saying that they built some kind of a tool they used internally based on an Arduino Due. The US Air Force was using an Arduino Due in that project. So sometimes, we get to know these people that, tend to use Arduino. So we understand that the needs change, the needs shift. Obviously, there were a number of companies that popped up. Like, there is this company in Spain called Industrial Shields. They built this thing that you can put an Arduino Uno inside this enclosure, and it expands the Arduino Uno to become essentially a PLC. Or there is companies building Arduino-derived hardware like Industrino that essentially build small industrial controller based on the hardware from Arduino. So clearly, a lot of these people and a lot of people building things, they gave us the direction, but a number of companies, they show up and say, hey, hi, it would be great if there was this. And so we start working with them, and some of these products happen. And also sometimes, we only figure out that people are doing a certain thing because they email us because they can't get something to work. But there's a ton of people who just never get in touch with us and use Arduino extensively in real applications.
The squeaky wheel customers I am familiar with. Like, why doesn't it work like I want it to work? Uh, let's talk shields a little bit. You mentioned shields. Are there a shield? Can you explain what a shield is? And are there any of them that are especially special, interesting, exciting, or surprising for you?
Well, so I guess I would say one of the ingredients that, in my opinion, made Arduino successful is this idea of a module that you can plug on top of an Arduino to add features. And that was done very, very early on in the history of Arduino. Actually, I would say the first shield was designed not for Arduino, but for a platform that was developed before. So one of my students did his thesis with me, and he produced this thing called wiring. And then we had a research project that was funded by a German university to build extensions for that. So I guess the first one that was developed was a motor control shield to control DC motors. And then obviously when we developed Arduino, we created that. The name shield comes from, I'll tell you this little story.
Please.
So one of my co-founders, David Quartiers, decided that since Arduino was the name of a king in Italy, this thing plugs on top of in a way, the king. So it's the king's shield in a way.
That's funny.
So back then it was like, yeah, why don't we do this? Sounds cool. It was this kind of randomness of when you're starting something from scratch and you have basically you're starting from zero. You have no competitors, nobody. You just do whatever because it feels funny, and so Shield starts from that. So yeah, obviously at the beginning things were like one of the first shields we developed ourselves was a biometric shield because I was working for an artist that was making this video game where the idea was that the players would keep their hands on some sensors, and depending on their emotional state, their character would become bigger or smaller. So they would, if they were calm, their character would be bigger and they would win more easily. So the first shield was essentially measuring heartbeat and skin resistance. But then, there are literally hundreds of shields. Somebody built a website called Shield List, and basically, after 400 shields, they gave up. There was just too many. I was like, "Okay, that's it.
There's so many.
Too much work."
It's amazing. It's like if you
So
want to do something, there's a shield that exists that just plops on an Arduino and goes.
yeah, also a lot of the silicon vendors started to make evaluation boards that were
Ah,
compatible with Arduino. So the people who make sensors, they make sometimes an Arduino shield that kind of plugs on an Arduino. And so it's funny to see that all sorts of companies, they have the familiar Arduino connector layout on their board.
yeah. It almost seems
So
like a
it's
standard spec these days for dev boards to have some Arduino
yeah,
compatible pins there.
it's kind of like when the PC had the ISA slots for expansion cards,
Right.
and that's kind of the ISA slot of of the microcontroller
Yeah.
world.
You mentioned an Italian king, and I was doing some reading, trying to figure out, where did the name come from, and I found this king, and I was looking for parallels, and then I found this article explaining how Arduino's name actually came to be. Can you share that with us?
Well, so so me and my friend David Quartier started kind of to work together. He was a visiting researcher at the school where I was teaching, and so we started to work on this platform that would become Arduino. Then we had to make this PCB because we had to send the PCB to Sweden because a friend of us, Livia, was supposed to run the first workshop with Arduino with actual people. So we had to finish by March 30th. And so we didn't have a name. So we were like sitting there, and the guy from the PCB factory calls and says, "Look, if you don't send it to me by 12, it's not going to be ready by March, by the end of March." No? So like, oh wow. So we start to think about a bunch of names. And so, the city of Ivrea is a small town, which is kind of interesting because it's a bit of a Silicon Valley for Italy, because that's where the Olivetti company was formed. So for a long time, they were making computer, designing computer, making stuff. So, but one of the things they are very proud is that they gave birth to this guy called Arduino, that was like the king of Italy in the year 1000. But then effectively, a lot of things are called Arduino, including this bar where I used to go get drinks at happy hour. So I said, you know what? Why don't we call it Arduino like the bar? Then, we can always change the name later, but don't have time now. Let's just. So I had literally sort of a very ancient version of Eagle CAD on my screen, and I just clicked and I edited and I put Arduino, save, and I sent the file. I think it
Was
was
this a
March 17.
was this a ploy for free drinks at your local bar, or are you kind of a local legend now for that? Or
No, no, I wasn't trying to get free drinks, actually. It was funny because the bar changed name over the years, but when it was still called Bar Arduino, people learned the story and they had some tourists show up in Ivrea and go to this bar to look at the place that gave the name to Arduino. So this guy who used to run the bar was like, there are these people coming asking about this Arduino. I was like, well, sorry.
I'm
But it
sure
was
there's a
interesting, like,
yeah. I'm sure there's a Barduino shield out there somewhere, right?
yeah, probably. Yeah, also I did during the lockdown last year, I did this streaming show, and we call it Bar Arduino, no? Because also in Italian, bar is not really the cocktail bar like in the US sense. It's not like the dive bar, but effectively we call bar also cafes where you get an espresso. So these
Okay,
cafes, like during the day you get espresso, and during the night you get happy hour. But they are a place where you go and discuss things. No, so for me, sometimes you say to your friends, hey, let's go to the bar and talk. No? So
for
this
sure.
association between Arduino and the bar still stays, still exists.
Fair enough. Fair enough. Now, Arduino has found astounding success in a lot of areas. Can you talk a little bit about where the holdouts are? Who are the, I'm going to say grumpy folks, but the people in the markets that really don't want Arduino or are a little more hesitant?
So when we started working on Arduino, our objective was clearly not trying to replace embedded engineers or the people who do that professionally. So our idea wasn't to try to enter into that market, but the idea is that this market can be expanded to actually work with the people who want to use the technology but don't are not professional. So I can when I was a child, it was a time where people started doing electronics as a hobby. So there would be magazines, there would be kits, you would learn by soldering. Then you would see, for example, electricians that didn't really know anything about electronics. They would buy the kits from these magazines, they would solder them and use them, for example, to solve little, you know, to provide small solutions for their customers. So there was really, but obviously, a number of people in these kind of professional fields, they thought that we were trying to go after them. So there was obviously a number of people that described Arduino in various ways, like the famous Arnold B from this forum described Arduino a baby talk language for potheads,
Oh no.
because it's very interesting how for some people, if you're an artist or a designer, you're clearly, doing pot, because it's kind of very 1960s vision of. So obviously there
Seriously.
was this kind of, pushback, but effectively I was like, I don't understand what you want from me because I'm not trying to do what you do. Um, but I guess in all these different in technology, there's always an evolution. So, for example, people used to program microcontrollers and microprocessor in assembly language and then burn EPROMs or ROMs, and the process was done by hand. And then people started to use C, and then there was like people pushing back on C because you don't have
Sure. It's not the
controller.
register
And
link.
then it
It's not
became
assembly
C++.
link.
plus plus.
Yeah.
So we started using C++ for Arduino. And obviously, this was, oh my God, no, C++ in an embedded device, are you crazy, no? And now people are doing Python,
Yeah.
MicroPython on devices. Oh my God, you're running Python on a device. The
If
world
it works.
evolves, and it works. Back in the days, in order to program a computer, you were wearing one of those white aprons. You were sitting in a data center, you know. And now anybody at home is doing some programming, even if they don't realize they're doing programming. Somebody writing some formulas in Excel, they're doing something that used to be done by large mainframes.
Yeah, I have a drawer behind me somewhere of chips where I burned the burned the register with the wrong value, and now they're basically wiped out. And I haven't done that with any of my Arduino boards, thank goodness. I think the IDE is one of the underrated parts of the Arduino ecosystem. Can you speak a little bit to the importance of that and the engineering effort that went into making that a reality?
Yeah, so I think you're right because effectively the reason why the Arduino IDE is downloaded that insane amount of times every year, it's because it's not used only by Arduino products. It's also used by, for example, people who use ESP8266, EXP32, people who use different kind of ST microelectronics boards, and others. Because at some point in the history of the Arduino IDE, we decided to basically allow anybody to plug a new backend to the IDE. The IDE starts from this as an interesting history because I would say, yeah, in 2001, two students from MIT, back then they were masters slash PhD students at MIT, they created a programming language and a development environment to teach artists and designers how to program. And they basically came up with a lot of, in a way, the concepts that resonated a lot with us when we worked on Arduino or when my student Hernando worked on wiring. So, to the point that one of the reasons why we started to work on these tools is because we wanted to make a hardware version, something that could program hardware, but with the same kind of high level ability to abstract that processing had. So in fact, the classic Arduino IDE is a Java application. It's the processing IDE with the Java backend ripped out and replaced with a C compiler. But then obviously over the year, we try to keep it always very, very simple. So there are 7 buttons on the toolbar and we're not adding any more because we believe that the simplicity allows people to just be productive very, very quickly. There is a big, big issue with a lot of the professional tools. When you try to teach to beginners, if you open a development environment, there is a gazillion buttons. Or even worse, there are development environments where there's no buttons and you need to open a command line and you need to know what to type in order to make something happen. So you don't even have the menus anymore. No, you have to. Obviously, that appeals to certain users, and that's great. But the problem is the beginners don't know where to start, and so they get put off and they give up. While the Arduino IDE kept that simplicity. Obviously, that thing cannot continue forever. So we started 2 different directions. One, we created a cloud-based development environment. So if you have a browser, you can log in and you can code Arduino in the browser. It's used a lot in schools. It's used a lot by people who develop. They sometimes it's even faster to compile in the cloud than to compile on certain Windows machines. So it solves a ton of problems for a certain type of customers. And then we created the Arduino IDE 2.0, where we started with this tool called Eclipse Theia, which is a framework that's derived from Visual Studio Code. And so we have a new development environment that it's out now that anybody can download, where you get modern features like in Visual Studio Code, for example, you get autocomplete, you get debugger, so you can do low-level debugging into an ARM processor if you have a JTAG probe. A lot of different kind of sophistications into the tool. So it looks a lot more like. And one thing that's kind of a behind the scene hero in all of these things, it's the Arduino command line interface because it's not very well known. But obviously, a few years ago, we created this command line tool that does all of the things that the IDE does, but without user interface. So and so it's very simple. You can do Arduino new, name of your project, creates a new project. Arduino compile, compiles. Arduino upload, upload. So you, and this is one single binary file. It's written in Go, so it's one single binary file. The installation is you take the file and you copy it, and that's it. I
Interesting.
think, and so now this is becoming the backend for all these different IDEs, because a lot of users want command line because they want to use it with their own tool, and also because people who are using Arduino in actual production, they have continuous integration tasks that are happening also on Arduino. For example, Google has this library they call TensorFlow Lite Micro, which is TensorFlow for microcontrollers. And they have a continuous integration task that uses the CLI to compile the new versions of the code and see if there are errors. So, so we went from a very simple, quote unquote, let's call it toy IDE to a family that has different tools depending on the kind of work you're trying to do.
Fascinating. So another example, I guess, of Arduino moving into an environment that professionals are more comfortable with, professional engineers are more comfortable with. Where do you see this going for, say industrial applications or other places in the next year, in the next 5 years, and maybe even 10 years down the road? Where is all this headed?
So two directions that I'm very interested in and we are very interested in, and I think it's one of the directions that the industry is taking more and more is the low code slash no code direction. So more and more tools, they basically say you will be able to build this kind of application by writing almost no code or literally by not writing a single line of code. No? And I think that trend is something that we are obviously following because, in a way, Arduino has always been a low code environment. Now, you could blink an LED with 5 lines of code. Also, this idea that it works out of the box, that you double click, install it, open it, press the button. 2 minutes later, you're doing something useful. To us, it's super important. And it appeals to a bunch of users. They don't want to deal with large software installation, with complex languages, even licensing issues. They just want to get going. And I think that's a direction that, for example, our IoT cloud, which has grown quite a lot and it's now it's got a lot of feature and it's very reliable now. It's something that started off as a product for makers and now it's shifting to a product for small and medium enterprises. So, and again, that one allows you to do a lot of tasks without writing any code. And when you actually write the code for the microcontroller, it's a low code environment because depending on the kind of things you're trying to build, it will generate all of the difficult code for you. So you just have to kind of fill in the blanks and it works. So I think this is something that we will see more and more. So there will be a category of developers who build sophisticated, well-tested, robust software components. And then there will be other developers who take all these different components, plug them together, and they kind of write the glue, they write the logic that combines all these different modules. The same thing is happening in hardware. More and more things are on modules. You grab a module, you put it on your PCB. If you're working with wireless, you don't want to deal with antennas. You just take a module, you put it in, and that's it. So we can see this kind of modularization and this kind of, in a way, low code slash no code direction becoming very relevant also for all the different tasks that require machine learning application. So a bunch of people develop sophisticated algorithms, but most of the people, they just want to pick the right algorithm and apply to the problem they have and just get an answer. So again, so I think that's some of the directions that we will that we are seeing that we're following.
There's been a huge low code, no code movement for sure. And the modularity for me, yeah, the development times just are not getting longer. Nowhere do people have more time to develop something that it's always faster and always you want it to plug and play. So the modularity makes a ton of sense from what I've seen as well.
Yeah, also some developers working in companies, they told me with the current speed, I don't have the time to grab a tool that I have to learn from scratch that has a very steep learning curve, so that I have to download it and I have to spend a ton of time trying to get to understand it. Maybe it's a tool that doesn't have a amazing documentation. So, you know, a lot of people, they don't have that kind of time. They just want a tool they can use, build something useful that's debuggable, that if they have a problem, there's somebody they can talk to. In a
Yeah.
way, obviously, a lot of people are making fun of this, what's happening right now with Stack Overflow. No? But a
Yeah.
lot of people that develop with high level languages are now Googling, going to Stack Overflow and
Yeah.
finding the solutions. In Arduino, is the same. You Google, and there's 1.6 million people, 1.1 million people on the Arduino forum only. Imagine on the
Wow.
other website.
Yeah, it's like if the project doesn't exist, maybe I don't want to do it because I can't copy and paste code over.
Yeah, okay, obviously that's an issue, and but in a way, in a lot of situations, people in certain industries, they simply don't have the time, which means the money, to start with a tool that's radically new and requires a huge investment. Simply,
Yeah,
certain places not possible.
I hear that loud and clear. Uh, As we wrap up on time, because we're pushing our limit here, what are some standout projects for you over the years? And I see a robot arm behind you. Are there any really cool projects that you just didn't see coming and stand out as special for you?
Well, yeah, it's because every day, I check out social media and I find another project that's insane done with Arduino. But obviously, at the beginning, most of the 3D printers that people started to develop, they were based on Arduino. So that was crazy. Also, the early drones for me was, shocking to see people building all these drones with Arduino. And then, for example, we've seen a lot of interesting projects done around even the biology space, like people building, repurposing a 3D printer using Arduino to print biomaterial. Instead of printing plastic, they're printing cells. And people building tools to analyze DNA based on Arduino. One set of projects that to me was kind of obviously special is when the pandemic started to hit hard and people started to realize that they didn't have enough equipment in certain hospitals, especially ventilation equipment. People started to design a ton of open source versions of these tools, and almost all of them used Arduinos. And then it's interesting because they might have used the Chinese copy of an Arduino to develop the device, but then when they actually had to go and build them, there was a British university that bought 7,500 units from us of an Arduino board to put in these ventilators, because at the end of the day, you know, so it was quite interesting that they talked to us to get a tool that they thought it was, they considered reliable and robust, to put into these tools that they sent out around the world. And that for me was just
Yeah,
incredible, that they would do that. And this university in the UK actually built a few thousand of these things and shipped them out to different countries. So
that's fantastic. You mentioned
it's pretty
briefly
amazing.
clones. this might get me on a interviewer blacklist somewhere, but I think they say imitation is the best form of flattery. Can you speak to the Arduino clones that are out there? What's that all about, and how do you interact and feel about those?
Well, I think there are different categories of kind of products that are derived from Arduino. One that obviously we don't like is what we call the counterfeit Arduino. So people who take the design of an Arduino board, but they also copy the brand and the logos and the graphics, because the brand and the logo and the graphics is the only thing that we have. It's registered that it's owned by us. So anybody can just download the file and make an Arduino. So these people are particularly annoying because they obviously, they impersonate us. And it breaks my heart when people write to our support saying that they have an Arduino that's broken. And then we look at it and say, okay, can you take a picture and send it to us? We look at it and we say, sorry, but that's a copy. We can't do anything for you. I'm sorry. Then obviously there's a world of companies, mostly Chinese companies, making very low cost copies. Obviously there are customers that are interested only in the price. And so there's, manufacturing in Europe to certain standards will never be cheap. Right. I remember once I was in Shenzhen and I was talking to the founder of Seed Studio, Eric Pan, and he told me that there were people there that they were building circuits, they were building Arduino clones by using parts disordered from discarded electronics.
Oh, no.
So in order to keep the price incredibly low, they recycled the parts. And a lot of people have had problems over the years. And, if somebody's parameter is only price, there's not very much I can do, as long as I don't try to pretend to be us. So we do have a number of, we work with a number of companies that protect intellectual property to deal with the people who pretend to be us. But the cloners are part of the, even if Arduino wasn't open source, considering the size of the market, it would have been cloned anyway.
Yeah, and I know that I remember hearing there was an interview you did on the Moore's Lobby podcast. So we kind of glossed over some of that setup stuff that was discussed on that episode. But you did mention in that you have from the beginning worked to keep the price stomachable for folks like students in a lot of these cases. I want to run a name change by you because we're out of time. Instead of branding, they always say is very important. Okay. Instead of Arduino, how about Arduino yes?
That's interesting. Yeah, we have to
take it as an enhancement.
I understand that the fact that it ends in O sounds negative, but interesting. Arduino, yes.
You can pass that back to your product team, and I'll send you my billing address if you come up with it.
I'll talk to the marketing team, and I'll let you know.
What a treat to have him here today. Also, thank you again to OKDo for sponsoring today's keynote. Visit their website at okdo.com. It's exciting to me to see the full spectrum of educational kits to professional solutions and what potential that holds for the future of engineering. I'd love to hear and see how you're using Arduinos in your projects, so put them up on social, and Massimo may be browsing those later. Also, go check out the other sessions that are happening today, and browse the exhibitor booths on the virtual trade floor. Those are live 24/7 all week. I'll be right back here tomorrow for the keynote at the same time with astronauts Victor Glover and Michael Hopkins. You're not going to want to miss it. It'll be out of this world. Thanks for tuning in. I'm Daniel Bogdanoff, and I'll see you tomorrow.